Corrosion is one of the greatest enemies of a ship and its machinery. It is also the toughest enemy to fight against, especially for people working on board ship. Iron is one substance which is used in abundance in the ship. From the main body of the ship to the smallest equipment used, iron makes its presence felt in almost every type of part and system used on board. Ships are often exposed to very harsh marine environments. Due to the environment in which they operate, the ship's hull is often vulnerable to environmental corrosion. The corrosivity of seawater as regards to general corrosion on steel increases with increasing temperature, oxygen content, water velocity, the content of corrosive contaminants, eroding particles, and conductivity. The seawater containing salt forms a perfect electrolyte with the ship's hull, which is fully made up of iron or mild steel in order to form a galvanic cell. Excessive corrosion can lead to total failure of a part of a ship or its machinery. When two dissimilar metals are in contact with each other in the presence of corrosive medium or electrolyte, the more active metal in the galvanic series acts as an anode and undergoes corrosion. This means in a galvanic series of metals, the more active metal acts as anode and undergoes corrosion, and the less active metal acts as cathode and stays protected. This electrical current is referred to as corrosion current and is nothing but a metal ion and electron transfer process from the anode which dissolves and passes into the solution. This simple cell where the corrosion process takes place is called a galvanic cell. In order to fight against this corrosion and protect the parent material, sacrificial anodes are used on ships. Metal strips of top order metals in the reactivity series serve as anodes and are installed for cathode protection. These are called sacrificial anodes. The anode is divided into two parts, namely anode insert and the anode body. Out of these two, the one which serves as an anode in the process of electrolysis is termed as anode body, whereas the other is called anode insert, which is used to securely fix the anode to the parent surface. Anodes are categorized under a variety of parameters. As per the classification of anodes on the basis of their shape, there are 6 types: flat or block shaped, teardrop anodes, cylindrical or semi-cylindrical anodes, disc shaped anodes, bracelet anodes, and tubular anodes. Also, according to the size of anodes, they can be of 2 types: small sized and large sized anodes. Whereas on the basis of material, zinc anodes and aluminium anodes are preferred in the maritime industry. The anode can be secured or fitted to the surface of the ship to be protected by 3 common methods, which are by use of brackets, bolts, and welds. Among these 3 methods, welding is the most efficient method which can maintain maximum electrical continuity and remain in the closest contact with the parent surface. Sacrificial anodes work on the principle similar to electrolysis, according to which if an anode and a metallic strip are dipped in an electrolytic solution, anode electron will dissolve and deposit over the metallic strip and make it a cathode. Anodes have to be changed only after they are completely decayed. The frequency for changing of anodes depends on the application where the anodes have been used. In case the anodes are attached to the ship's hull, then they are to be checked during dry dock, which takes place after 2 to 3 years. If the anodes are found completely corroded, then anodes of bigger size should be fitted. For a fully corroded anode, it means that the material used was of poor quality or a large amount of material is required to protect the hull. We now know from the galvanic cell and the sacrificial anodes that a potential difference between two electrodes is required for corrosion current to occur. This corrosion current dissolves the anode in the electrolyte. But in the absence of a potential difference within the ship's hull, the corrosion current will be at minimum. This is what the ICCP or the impressed current cathodic protection does. It makes the hull to remain always cathode by keeping the potential difference to a minimum and introducing a current opposite to the natural corrosion current, thereby protecting the anode. Impressed current cathodic protection systems are the technologically advanced and long-term solution to corrosion problems and are regarded as a superior alternative to sacrificial anode systems. In the ICCP, the metal to be protected is connected to an insoluble anode and current is passed using a DC source opposite to the corrosion current, so that the corroding material gets converted from anode to cathode and is protected from corrosion. This insoluble anode can be either platinum, platinized titanium, or any other inert elements. The same principle is applied to ships. Here, a contact point is taken on the hull of the ship and is connected to a reference electrode. This reference electrode is completely passive insoluble metal. The reference electrode measures the natural corrosion current, which is nothing but the potential difference between the hull and this reference cell. We need to measure this corrosion current in the hull so that we supply a DC current which is either equal to or slightly greater than the natural corrosion current and is in the opposite direction to the impressed current anode. This in turn supplies a protecting current to the hull of the ship, making the hull a cathode protected from corrosion.